To prepare the pH meter, we removed it from its container, rinsed it with deionized water, and calibrated it using 2 buffer solutions. Obtaining the pHs of the buffer solutions involved putting the electrode in the pH 4 buffer, calibrating it to pH 4.00, rinsing it with deionized water, putting the electrode in the pH 7 buffer, and calibrating that to pH 7.00. Testing a solution of an unknown pH involved rinsing the calibrated pH meter with deionized water, placing it in the solution, and recording the value of the pH meter once it had stabilized. To properly clean and store the pH meter, rinse it with deionized water, place it in its container, and store it so that it sits upright.
Go.
A buffer solution is an aqueous solution of a weak acid and its conjugate base, or vice versa. Buffer solutions act to reduce changes in pH when a strong acid or a strong base is added to that solution. In the case of adding a strong acid, excess hydronium ions will form. The conjugate base found in the buffer solution will react with those excess hydronium ions to form more of the weak acid. In the case of adding a strong base, excess hydroxide ions will form, and the weak acid in the buffer solution will react with these excess hydronium ions to form water and more of the conjugate base.
Okay, so a strong acid is one that completely dissociates in water into its ion forms, and thus it reaches completion and is irreversible, versus a weak acid that doesn't completely dissociate and therefore has an equilibrium that is reversible. And a buffer can reduce the pH changes in both.